I'm just going to show you the live demo, and I've structured this into 3 areas. So basically, the first thing is modeling. How does it work with Naval Architect? The second thing is how does the information management work? How can you connect different properties and characteristics of a ship with the model? And the last thing is, okay, if you have all those features, how do you actually work efficiently together with other stakeholders? So we call this engineering change management. I can also say version control, actually. So those 3 areas. Yeah, and by the way, so during the development process, and also now, we obviously used Hoops and Parasolid as the key SDKs during our development. So Hoops Communicator for web-based visualization, Hoops Exchange for data import and translation, but also Parasolid's 3D geometric modeling kernel technology. So they also played a huge role in the development process. And you can basically now see, if I switch my screen, how the product actually looks like. So just a short intro. So the first thing is, as I mentioned, 2D, 3D modeling. So you can see my screen, right? Okay. So you can basically have different views, 3D views and 2D views. And this is just an empty project. So where do you want to start? You want to upload a ship surface. This is, or you can use different file formats, right? IGES and STEP and so on. And there you have the ship model, and you can also look at the midship section. And now let's start to model a bit. Let's add a deck. I just draw something just out of my head. Shouldn't be too realistic, but anyways. So this is just the bottom part, and I can basically just create another one. It's probably the ceiling in this example. And you can see that in the 3D model, everything is updated accordingly. So this is what we call fast modeling. You can model in 2D and at the same time create a 3D model. So you save a lot of time, and it's quite efficient, and not so common in the current early design process, right? You basically, nowadays, you only model in 2D. So now you can define what's the ceiling, what's the floor, and then basically create a deck plan. So then let's also add some bulkheads. Let's just start from there. Okay. And keep in mind, this is a topological model. So yeah, if I draw this line here, and it basically connects between those 2 areas. And if I move one area, let's say the middle part, and this automatically recognizes that you will move the whole part. So this is a connected topological model, and you can see here in a 3D model it's also there. Obviously, you can have different rendering models. There's an X-ray, and let's also look at different cutting planes. You can see here right now nothing is inside. But if you go on with this and yeah, spend some more time, you can actually also add the GAP below it, and then be a bit faster, and then recreate the model basically, and then you can see that you can go a bit crazy with this, and then create a more complicated or more complex model. And now the question is, okay, how do you connect this with the properties and characteristics that I've mentioned? So right now we have added equipment. This is an engine. You can see on the right-hand side that this is connected with all the relevant properties. You can define for yourself what kind of properties you want to include. And on the left-hand side, you also have the structure. You can also be flexible in how you want to structure the whole properties and the informations you want to have. Obviously, you can load different geometries for the equipment as well, and for the components. And then you can just add this component to the actual view. All right, and for the last part, the change management. So here you have the basic marine, the structure here that you can also upload. So And then you can define, so any changes that you made, that you are making with this model, it will be synchronized with all the other users, and it will be recognizable in the version control chart in the end. So you can also, and it saves different versions. So you can basically jump into another version to see what has changed there. And you also have a master version. You can create different branches, and you can merge those changes in the end. So you can see I just changed the planning status from revision to approved. And in this change model, it will show you directly in which areas you have made changes and how many changes there are. Obviously, this is just an example, so you cannot see a strong version control chart there, but in the end, if you have different users and different versions, you have a longer version control chart and also different branches, and you can jump in to see immediately who has changed what at what time. And this is very helpful for the coordination process and also for collaborating. And this is a standard process basically in software engineering, and we want to bring this to shipbuilding as well.